Hello, this is David, and I want to apologize. In the last video, I said that we would cover hypothetical markets and start an introduction into market modeling. We never got to the market modeling. So we're going to pick up just where we left off in the last video, and where we left off, we had a number set here, or a set of data that was, same that we've used in the book. And this is a hypothetical market. It's the one we created. We made it up ourselves. So the good things about this is we know some right answers. When we go to extract the coefficients or the line item adjustment rates, we already know what the answers are, so we'll kind of know if we're right or wrong is the idea. How much of that we'll need here, I'm not sure, but we're going to set up a basic model. Now, a model is something that tries to mimic the market. And I'm going to have to say this because I'm sure I've done it and I will do it. I often will get excited about what I'm talking about, and where I mean model, I'll say market, and when I mean market, I'll say model. So you're going to have to kind of watch for that and be sure you're on track. This up here is a market, and it happens to be a hypothetical, but it's market data. It's about the market. And sometimes, or in real appraising, we'll use real data, not hypothetical. This is a model, and what it tries to do is mimic the market. So in this model, what we've done is we're going to look at just one coefficient. And let me do this. That'll be the best way to do it. And that is the gross living area. So in the model, it's a simplification of the market in this case. And almost all models are always simpler than what's really going on in the market. Because we know really in the market, it considered a value for gross living area, garage, quality, and effective age. So our model is very limited just to one gross living area, and I can change this number up here to whatever I want, and the coefficient will change. So what the model does is it knows the sales price, it knows the gross living area. Now it's going to say, let's try $80. Let's say, out of trial and error, let's just start with $80 for the gross living area and see how well it does. So we're going to take 1728 times 80, and we're going to get a predicted price, excuse me, based on the $80 coefficient, or the $80 adjustment rate. Now we have this. We have the predicted price for all of these. Now the residual is what we call the residual. Appraisers, you might think of error, but in statistics they call it residual, and no reason for us not to call it residuals. So we're going to take the actual sales price minus the predicted sales price, and we're going to get a residual. Excuse me. So you can see in this case, the model was off by 31,000, 170,136 minus 138,240. It's off 38. Okay, so we do that for each one of these 10 sales. All right, and we have some residuals. Now you can tell just by looking, this model of $80 is not very good, because we wouldn't want to miss our appraisal on a $170,000 house by 31,000. So we know it's not very good, but it gives us a place to start. So these are our residuals. It's very important to know how to calculate a residual. It's the sales price minus the model's predicted price. Now, we also then can look at residual. Sometimes 31,000, it's different if it's a $100,000 house or if it's $1 million house, right? 31,000 on $1 million house wouldn't be bad. So let's just convert this to percentages. The way we find the percentage of the residuals is we take the residual and divide it by the actual sales price. And that's our percentage. Okay. Now they can be a plus or a minus, and we'll see that in a minute. It just happens they're all pluses here. Then we're going to come over and we are going to actually make them absolute. Okay. Now we can kind of look at these residuals in our head, and we can see that they don't look good. We know this 80 is not good. This $80 is not good. We're probably going to want to start it with something else in a minute. But let's get away from this subjective looking at things, and let's look at these a little bit more objectively. So first of all, let's introduce a term here, MAPE, and that stands for the mean average percentage error. And that's kind of what this is. You know, we called them residuals. You know, could be, I said let's get away from error, but this is actually a statistical term. MAPE is a statistical term, so we're just going to use it. So that means the mean average percentage error. So that would be the average of all of these numbers, okay? So the MAPE is the average of these numbers. It's the average, the mean means average, of the absolute percentage, and this is the absolute percentage of the residuals or the error. So I can look at this and see that that's the average of these numbers is 15.1%. Okay, 15.1%. And I'm going to write that over here, 15.1. All right, now let's get back to a term that we used, and we've already covered it, and that's the average or the mean deviation. And remember, what we're saying is how much spread or disbursement is there in these numbers. We want it as well as the average. Okay, and since we've already covered that, I'm not going to go into this much. For these numbers, it's 4.2. All right. Now, the other thing that appraisers might want to know, if you're doing an analysis and you're trying to decide if your analysis is enough, you've covered your due diligence. In other words, would this model be enough for what we're doing? And we haven't defined any parameters for this assignment, so we're probably not going to be able to answer the question. But we know that's what these are for. One thing we might want to know, what was the very worst residual we got? And we use the formula equals the max of everything in here, maximum equal the max of these. You can see the formula up here, and it's 26.7. So we know we can be pretty far off. That's not too good. We know that. Now, what we can do then, let's try something else. For example, let's try 120 and see what happens. So when I put in 120, now this is the beauty of a spreadsheet if you're not used to it. It just changed everything, even all the way down to our residual chart, which we didn't talk about. We'll talk about it on this round. It changed everything on the fly for me. So I can try these over and over again and see what I get. Now, what we want to know is did 120 do any better than the 80? So it calculated predicted prices, it calculated residuals. There's the residuals as a percentage, and there's the absolute. And so now our MAPE, the average percentage error, the MAPE, is 27.4. It's worse than 15. We want these to be low. The mean deviation is 6.3. It was 4.2, so it's worse. The maximum went to 43%. You could be off 43%. So we know 120 is no good, okay? Now let's look at our chart here. This chart actually shows, when I click on one, it'll show you what it is. It shows these numbers right here. It shows the percentage of the residuals to the sales price, percentage of the residual to the sales price, and it plots them down here. And you can see that the one that's 43%, that's this one right here, okay? So that says 6, so it must be 6, and there it is right here, 6. So that's what that plots. Now, what we would like is for all these percentages to be 0, and they would line up on this red line. Now, one thing I know from what we would call, and see, what we're doing down here is we are actually now performing a residual analysis based on three descriptive statistical methods. See, we didn't get into hard statistics. We didn't get into inferential, where we infer things by samples. We're just using things that appraisers have always used. So, you know, I use the word statistics a lot. These are statistics, and I'm going to say it again. It's in the book. It's a little off track here. Appraisers use statistics all the time. We just don't use some of the more sophisticated statistics. We use statistics all the time. So don't ever say, I'm staying away from statistics. No, you're not. You use them every time. Every time you do an average. Every time you do a reconciliation. Okay, off the soapbox. Now, we can see this made it worse. So now we can try, let's try 100. All right, now I did 100, and I think you're getting the idea. We tried 100. You can see the coefficient of 100 times these gross living areas. And now we have our residuals. We have our residuals as a percentage. And now we can come down and try to we can see they're a little better, but let's objectively see what they are. Now this MAPE is 7.8%. That means on average, if you use this model as an appraiser to predict a price, on average, you would be about 7.8%. And on average, you would be probably a plus or minus 3.8% of that 7. Means you could be as low as 4. You could be as high as 10 off. But what's the very worst you could probably be with it is 19.5%. All right, now you can see, and I didn't mention it earlier, but when these are all positives is not good, and when these are all negatives is not good. It should be kind of a mix. So now I've created a table that I think is in your book. Well, I know it's in your book. And this table, I'll get rid of these now. This table is where we ran a residual analysis for the following coefficients: for $80, $94, $100, and $120. Now, I didn't put the 94 in, but how we got the 94, of course, was just to go up here and put in 94, and it calculates it. So one thing you can see here is that when you use some kind of a computer, whether it's a spreadsheet or whether it's in your forms package or wherever it is, these analyses are not time consuming. Once they're set up, they're not time consuming. Okay, so let me get this on over. So what we saw was here, when we did our residual analysis, the MAPE was 4.9, and that's on this table. This is the same table that's in the book. The mean deviation was 3.3, and the maximum it was off was 13.9. I did one other thing. I counted, excuse me, what percentage of time we were above the 0, and that's the 0 on this chart. How many times we're above and below? We can do it right here. We're 1, that's probably 2, 3, 4, 5. So we're 1, 2, 3, 4, 5. We're 5 above and 5 below, so that's pretty balanced. How else could we have done that? We could have just counted here how many negatives. 1, 2, 3, 4, 5 negatives, so you could also do that. So we've got 50% plus or minus. We looked at the maximum. We looked at the mean deviation, and it looks like I didn't leave the mean deviation where you could see it. And we also looked at the MAPE, and we also looked at the mean. So when we did this, kind of rambling there, when we did this residual analysis, then how many different things did we look at this? You know, how many ways did we do our analysis? We did 3 here, but actually we did 4 if you count the number of positive, as opposed to the number, the right answer here would be 50%. That's 100%, it's way off. That's not good, and that's not good. Now, so what we're saying is, if we were going to try to predict a price, we would use $94 a square foot with this model.